Have you ever wondered how the narrative of existence began? This vast expanse of time and space, the cosmos and its ceaseless dance, the echoes of creation and the silent whispers of the end. Where did it all start? The earliest known epoch of the universe, the Planck era, marked the inception of this grand narrative. It was a time less than a trillionth of a second after the Big Bang, a moment when the laws of physics as we know them ceased to exist. It was a time of uncaused, undirected motion, a vacuum fluctuation eruption in an indefinite realm, a realm as close to nothing as can be. Yet it was not nothing, for it was a realm of energy, and energy, as we know, cannot be destroyed. From this primordial era, the universe unfolded. Time evolved, space expanded, particles formed and annihilated, all in a cosmic ballet of creation and destruction. The quantum foam, the birthplace of virtual particles, was the constant backdrop of this cosmic drama. These virtual particles, these somethings of possibility, came into existence, participated in the narrative, and disappeared, leaving no trace behind. Yet, even in their ephemeral existence, these particles were part of an information process. They had a meaningful existence, for they contributed to the cosmic narrative. They were the building blocks of the universe, the fundamental arts from which everything else was born. And this narrative, this cosmic dance, is not random. It is a symphony of relationships, a grand design where everything is relative. The universe is not a stage set against a backdrop of absolute rulers or clocks. Instead, it is a cosmic ballet, where each dancer's movement is in relation to another's. This is the story of the universe, a narrative that has been unfolding for billions of years. It is a story of causeless events, of energy and information, of creation and destruction. It is a story that has no beginning or end, for it is a circle, a cycle of existence. In summary, the universe began in the Planck era, a time of uncaused, undirected motion. From this primordial era, the universe unfolded in a cosmic ballet of creation and destruction. The quantum foam, the birthplace of virtual particles, was the constant backdrop of this cosmic drama. These particles, though ephemeral, had a meaningful existence as they contributed to the cosmic narrative. The universe is a symphony of relationships, a grand design where everything is relative. It is a story that has no beginning or end, for it is a circle, a cycle of existence. The secrets of the universe lie in understanding this cosmic narrative. It is a narrative that has been unfolding for billions of years, a narrative that is still being written. The universe is a story of existence, a story that we are all a part of.
Have you ever wondered about the true age of our universe? How it all began? Or what happened in those first crucial moments after the Big Bang? Welcome to the second part of our journey through the history of all history. As we delve deeper into the mysteries of our cosmos, we find ourselves at the very beginning, a time when even time itself was a budding concept. Imagine a cosmic stage set for the grandest of performances. At this point, only a fleeting moment after creation, we find ourselves in a gut transition, a period of unfathomable brevity, where the strong force separates from the electro-weak force. This separation, quick as it is, gives birth to a beautiful balance. The strong force, which would later provide stability, and the weak force, the harbinger of change, come into existence. Then, perhaps, inflation begins. A slow, rolling scalar field generates negative pressure, leading to an exponential expansion of space-time. Picture an energy density of a staggering 73 tons per cubic centimeter, doubling itself. These quantum fluctuations create nearly scale-invariant variation in energy density. Just like that, the enigma of the immortal universe unfolds itself. Though this inflation theory remains a proposal, it provides the most plausible explanation. The galaxies we see today are perhaps the quantum fluctuations that have been etched onto the grand canvas of the night sky. The universe then plunges into the quark era, a time when quarks and superparticles dominate matter content. The quark-gluon plasma forms, and quarks can never exist independently again. This era witnesses the birth of gravity, grounding us to the universe. Following this, the electroweak transition takes place. The electroweak force, under the action of the Higgs mechanism, breaks symmetry. This marks the birth of the photon, the particle of light. Standard model particles acquire mass, photons guide us, and the universe takes another step towards complexity. The universe then enters the hadron era, where protons, neutrons, and pions form. These are the building blocks of our future atoms. This era also sees a brief period of annihilation of protons and neutrons with their antimatter counterparts. However, a slight favoring of matter over antimatter ensures the survival of some protons and neutrons. To sum up, our universe has come a long way from its humble beginnings. From the separation of the strong and weak forces, through the era of inflation, the birth of gravity and the creation of light, to the formation of protons and neutrons, the universe has been on an epic journey. Each stage of this journey has been instrumental in shaping the universe as we know it today. And remember, this is just the beginning, the first few moments in the life of our universe. So sit back, marvel at the complexity and beauty of it all, and stay tuned for the next chapter in the history of all history.
What happens when electrons and positrons annihilate, leaving behind a minuscule fraction of electrons, Austin? This is where we see a beautiful symmetry taking place. The total number of electrons equals the total number of protons, each balancing the other out. Protons carry a positive charge, while electrons are negatively charged. From 10 seconds to 57,000 years, we're in the radiation era. This is when photons, created from the annihilation of matter and antimatter, dominate the universe's energy density. Light has been let. We are set to shine. But shining is a slow process, isn't it, Austin? It takes a staggering 4 billion years in bioevolution. Between 1 to 5 minutes, nucleosynthesis begins. The fusion of protons creates helium, deuterium, and trace amounts of lithium. Some of our basic elements are already there. Hydrogen, being the simplest, is present. It's fascinating, Ruby, how complexities form from the simple. At 57,000 years, matter and radiation reach equality. The radiation density, which includes photon and neutrino, equals the matter density, comprising dark and atomic matter. This equality is due to radiation density falling more quickly because of the stretching of the relativistic particles' wavelengths. The first sounds of the universe come forth as the word, when atomic matter begins oscillation due to the battle between gravity and photon pressure, generating acoustic oscillations. At 380,000 years, recombination occurs. The temperature falls low enough to allow atoms to form and photons decouple. The cosmic microwave background, or the CMB, is born, locking in its structure the story of the earliest times in the universe. For 5 to 200 million years, the universe goes through a dark age. The atomic gas continues to fall toward the dark matter clumps, which grow more pronounced. The first stars are formed, bringing an end to the dark era. And finally, at 200 million years, we have the first stars. These massive, short-lived stars emit some lower atomic elements and die in violent supernova explosions. These explosions fill the cosmos with higher atomic elements, building dust for new stars and the planets of solar systems and the elements for life. To sum up, the universe's history is a symphony of matter and energy, oscillating between creation and annihilation, light and darkness, simplicity and complexity. Every stage, every era is a testament to the intricate dance of particles and forces, shaping the universe as we know it and as we continue to discover it.
Imagine, if you will, a universe in its infancy. a mere 1 to 2 billion years old, where baby galaxies are forming from merging groups of stars. Picture a cosmic ballet of galactic collisions, high birth rates of stars, and a flurry of supernovae. This heavy element production shifts the pattern of star formation, leading to lower mass, less luminous and longer-lived stars. The second-generation stars we see today. It's a cosmic stage, set for the emergence of life, readying itself to have eyes to see and minds to comprehend its grandeur. Yet, as Austin so rightly points out, this soon takes another staggering 10 billion years. Moving forward in time, we reach the 2 to 3 billion year mark. In the midst of frequent galaxy collisions, the star birth rate hits its peak, as does the formation and feeding of supermassive black holes. These darkling beasts seem to be lurking, their ominous presence a stark reminder of the universe's relentless dynamism. Fast forward another couple billion years and we encounter the early life of bacteria. These minute organisms that took 2 billion years to create Earth's atmosphere by exuding oxygen as a waste product. 6 billion years into the universe's history, the first rich galaxy clusters form. By 7 billion years, the effects of dark energy kick in, causing the universe to once again accelerate its expansion, albeit more gently. Gravity, it seems, has lost the battle. At the 8 billion year mark, the first modern spiral galaxies form. 3 billion years after that, the density of matter, both dark and atomic, equals that of dark energy. And at 9.1 billion years, our Sun and Earth form, setting the stage for the emergence of humankind in the cosmos. From the formation of galaxies to the birth of stars, from the creation of Earth's atmosphere to the emergence of life, the universe's history is a tale of unimaginable scale and complexity. It's a story of collisions and formations, of birth and death, of emergence and evolution. It's a testament to the universe's relentless dynamism, its ceaseless creation and transformation, and it's a reminder of our place in this grand cosmic narrative, a narrative that continues to unfold with every passing second. And as Ruby and Austin's dialogue reminds us, it's a narrative that's inherently linked to our own. For the emergence of humankind in the cosmos has set the stage for our existence, our interactions, our relationships, and yes, even our love.
Ruby, have you ever wondered what the future holds for human civilization? As we stand here at the precipice of time, some 13.7 billion years since the dawn of existence, we find ourselves at a potential zenith, or possibly the onset of a steep decline. The reason? Overpopulation, resource depletion, and environmental destruction. These factors could lead us down a path of conflict as nations grapple for the ever-diminishing resources. Yet there is hope. If we are to believe that our species is not typical, we could solve these issues by developing communitarian economic social structures that balance our needs with available resources. It's a tall order, no doubt, but one that we must strive for if we are to secure our future. Austin, it's a daunting prospect, but with the right steps, we could potentially rewrite our future. Scene script, Ruby, do you know about the 6 near extinctions Earth has faced? Let's delve into this a bit. Imagine our planet's long history as a book. Each chapter tells a story of survival and extinction. Now, let's turn back to 6 crucial chapters, each marking a near-extinction event. The first chapter takes us back about 444 million years to the Ordovician-Silurian extinction. An intense ice age froze the planet, and nearly 85% of sea life vanished. Then came the late Devonian extinction, around 375 million years ago. This time it was the plants that took a hit. Their unchecked growth depleted the planet's oxygen, suffocating most aquatic species. Fast forward to 251 million years ago. The world faced its most catastrophic extinction event, the Permian-Triassic extinction, often dubbed the Great Dying. 96% of all species were wiped out, a shocking reminder of how delicate life can be. The Triassic-Jurassic extinction event followed, around 200 million years ago. It opened up the path for dinosaurs to dominate, as many of their potential competitors were wiped out. Then, around 66 million years ago, the most famous of all extinction events occurred, the Cretaceous-Paleogene extinction. A massive asteroid strike wiped out the dinosaurs, but guess who benefited from this calamity? Mammals, including our very own ancestors. The last chapter brings us to about 2.5 million years ago, the Pliocene Quaternary glaciations. The Earth's temperature dropped dramatically, triggering a series of ice ages. Many species couldn't cope with the cold and went extinct. But each of these near extinctions also sparked new beginnings. Life adapted, evolved, and persisted through each calamity. For instance, the extinction of dinosaurs paved the way for mammals to thrive, leading to the evolution of humans. So in a way, we owe our existence to these past extinctions. Austin. So every cloud does have a silver lining. Our existence might not have been possible without these extinctions. Ruby. Speaking of theories, have you heard about the Young Earthers? Now, this is a group that's taken a rather unique stance on the age of our planet. According to them, Earth is a spry young thing, barely over 400 years old. Yes, you heard that right. 400, not 4 billion. Now, as you can imagine, this theory has sparked quite the controversy in scientific circles. It's a significant departure from the widely accepted age of Earth, which is around 4.5 billion years. Critics argue that the Young Earthers theory lacks substantial evidence, particularly when we consider geological formations, radiometric dating, or even historical records that go back further than 400 years. Nevertheless, the Young Earthers remain steadfast in their belief, challenging our understanding of the world around us. After all, isn't that what science is all about? Austin. It's fascinating how different theories can be about the same planet we all live on. Ruby. Now let's dive into the concept of the block universe. This theory proposes that past, present, and future all exist simultaneously in a sort of four-dimensional block. But here's where it gets complicated. If the universe is indeed a block universe, it implies that the future is as definite and unchangeable as the past. But how can that be if the future is infinite and complex? Imagine the universe not as a static block, but rather as a dynamic, ever-evolving entity. This is where Lee Smolin's work on presentism comes in. Presentism posits that only the present moment exists, and the future is not set in stone. It's a fascinating counterpoint to the block universe theory, suggesting that our actions and decisions truly do shape the future. Austin, it's intriguing to think about how our understanding of the universe continues to evolve. Who knows what we'll discover next?